So guys, you can see that PIC16F877A has a resolution ADC module of 10 bit. That is what the data sheet says. See, it has a ADC module of 10 bit, and then if you go here, it says that it has 8 channels. See that we have 8 channels, AN0, 1, 2, 3, and up to here AN7. This means that AN0 to 7 they are 8 channels. So let me give you a little bit of description. So 8 bit means 10 bit of ADC means 2 power 10 is equal to 1024. It can have maximum values of 0 to 1023, because in case of computer we also count 0. So maximum will be 1023. So the input voltage, analog voltage, can be from 0 to 5 volt. Now the ADC pin have to convert this analog voltage in terms of digital voltage in this form. So if 0 is 0 volt, 1023 is 5 volt, rest you can apply simple formulas that you know in the math. So it means that 2.5 is half of the 1023, so it will be 511.5. Now 5 volt is 1023 is digital, and these values like this side, digital side, can be processed, and that is why we use the ADC modules. Simple. Welcome to learning microcontrollers. In this video, I will give you a theoretical explanation of ADC module of PIC16F877A. I will be using a datasheet and the programming library of Micro C for PIC for explanation. So let's get started. So guys, first of all, let's get to the datasheet. I want to show you something. So in the datasheet, if you go to this page, I will share the link to this datasheet as well in the description. So you can see that the PIC16F877A is included in this datasheet. And as you can see, let me zoom in so I can take you what I want you to see. So analog feature, it says a 10-bit ADC having up to 8 channels of analog to digital converters. Now, if you go down here, you will look that this is 28 pin. This is okay. This is the one DIP version. Here you can see that A and 0. These ANs are the ones we are looking for ADC pins. So AN0, AN1, AN2, AN3, and now this is not an ADC pin. In the port A, this is the pin AN4, AN5, AN6, AN7. So from 0 to AN0 to AN7, there are total of 8 channels. So that is what this line means. So we have one ADC module having 8 channels. Like it's a single 10-bit module and it has like 8 channels. So if I like open some notepad and I want to explain to you what I mean. So let me write something here. I just increase the font size to 72, bold, copper. Okay. Okay, what I say is that suppose PIC16F8, as per the datasheet, PIC16F877A has an ADC module of 10 bit. Okay, and it has 8 channels. Now these two lines are very important. Now first of all, let's get to this, that what we mean by having an ADC module of 10 bit. 2 power 10 is equal to 1024. So it means that 0 to 1023 in terms of computers, because computers also count 0 as a digit. So 10240 to 1023. So this means that PIC16F877A has an ADC module of 10 bit and having a resolution. Now this is the resolution. Resolution equals to 10 bit. Now this is perfect. So it can read characters from 0 to 1023. Suppose the ADC pin is supported 0 to 5 volt. Like we are giving 0 to 5 volt to the ADC pin. Okay, like this. So let me show you what I mean. So here you can see that this over here, okay, this is our PIC16F877A and we have like 8 ADC channels. So I take only this one, the ADC pin number 1, channel 0, A0, and then there is the ADC input 0 to 5 volt, any like a potentiometer or any ADC module like a sensor of some sort, smoke sensor or some other sensor, and it gives a signal of 0 to 5 volt variable signal to the A0 pin. Now in this scenario, what I want to show here is that suppose we will get 0 to 5 volt DC. Now how will we be able to use this? Now what is an ADC module? What is an ADC module first? Now that is the first question. ADC stands for analog to digital converters. converters. Okay, and what is analog? Our normal DC voltage is an analog signal. Like we are getting a normal DC voltage, that is an analog signal. So a computer cannot like process this signal. The problem is with the analog is that why we need the ADC is that analog cannot be processed by CPU. Now that is the problem. Now to process it, we need to convert analog to digital to be processed. Now that is the problem. That's why we use the ADC converter, because we get the analog voltage from a sensor or a module like 0 to 5 volt. Now this is an analog voltage. Once it's converted to digital, only then it can be processed. Now we continue from here. Okay, we have a resolution of 10 bit and the sensor is gives a value from 0 to 5 volt. Now once how the ADC will work. Now to make the ADC work, let's get to the micro C for better understanding. Now in the micro C, if you go to the right, you have this ADC library. You just check mark this and go to this command called ADC I90. Now this is the initialization command of any PIC microcontroller. Now there is this command, this is important, ADC read. Double click on it. Now what it says in the description here, it says that initializes the PIC's internal ADC module to work with the RC clock. Parameter channel represents a channel which the analog value is to be acquired. Refer to the appropriate data sheet for channel to pin mapping. Okay, that's perfect. That's what I have already shown you, that A0, AN1, AN2, AN3, etc. Now this is the command here. Now what this command says that suppose you have a variable called temp, an unsigned integer. Temp is equals to ADC read 2. Like it will read the ADC value from the channel 2. Now the ADC value, now the thing is your ADC module is able to get the value. Now the value got will not be 0 to 5 volt. From the channel 1, channel 2 or channel 0, we are getting 0 to 5 volt. But in terms of computer, it will be divided into digital steps. So let's continue this. Okay, we got resolution of 10 bit, 0 to 5 volt ADC. Now 0 means we have a resolution of 10 bits. So 0 to 5 volt is to be taken in ratio of 0 to 1023 in case of PIC16F877A. Now that is the point here. Now 0 to 5 volt will be mapped in terms of 0 to 1023. Now how? So suppose I get a voltage of 2.5 volt. So this means that it is half. So 2.5 means 1023 divided by 2, because it is half here, so it will be equal. So like 2.5 means half of, like it will be something 511.5 or something like this. So this means that 2.5 volt is reached. So this will work in ratio. That is how the ADC module works. You just convert the input voltage and map it to the resolution of 0 to that voltage. So in this way your ADC modules work. It converts this into digital. Now the importance of these ADC values is that, like for the 5 volt we have 0 volt. For the 5 volt is equal to 1023. This 1023 is digital and can be processed by the CPU. So that's why we need the ADC module to like make any analog voltage digital and processable by the CPU. So guys, this is it. That is what I wanted to tell you here, is that how we process the ADC data and how we use the ADC module in PIC16F877A, and similarly it works with every microcontroller in the world. So if you guys learned something from this video, that is all I wanted. So if you have any question, you may ask in the comments. So we'll see you in the next lecture. Goodbye until then.